method called substitution. A little different than elimination. Okay? Here's how it works. Just like before, we have two linear equations, and what we have to do is we have to find where these two linear equations cross. We can graph them. One may be like that, one like that. We're looking for that spot right there. And what we need are both the x and the y coordinates for that location. All right, now, like before, with elimination, we were adding equations together to make things disappear. But what happens with substitution is that you take one of the equations and you solve for one of the variables. So what I'm going to do is I'm going to take equation 1 and I'm going to solve for one of the variables. I'm going to solve for y because it's the nicer one of the bunch. Okay, so this step looks like this. We have 3x minus y is equal to 5. So when you solve for y, it means you want to get y by itself. So I'm going to take the 3x to the other side. And when I do, of course, it changes from a positive to a negative. The 5 stays positive and it looks like this. Well, we're almost there. We have negative y. We need positive y. So if we divide everything by negative 1, the negative 1 in front of the y will divide out. We're left with 1y. Here we'll be left with positive 3x, and here we'll be left with negative 5. And so now we have an expression that is in terms of one of the variables, or we know that y is the same thing as y, same as 3x minus 5. Okay, and so what we're going to do is we're going to use this fact to solve this system. So here's what we do. Since y is the same thing as 3x minus 5, or actually you think about it the other way around. Since 3x minus 5 is the same as y, wherever there's a y, we can put this thing in, and it's the same. Now, there's a special place to put this so that this process works. What happened is we've used equation 1 already. We've used equation 1 to solve for y. So now we're going to use equation 2, and we're going to replace the y that's in there. All right, so what does that leave? That leaves, actually, let's write this to start with. That is equation 2. And we're going to replace the y with something good so that we can solve this problem. And the something good is down here. Y is the same thing as 3x minus 5. So this y is the same thing as 3x minus 5. Now the beauty of this is that there's only one variable now, which means we can solve this. Okay, so we now to solve for this one variable that we have, use the rules of algebra that you know and love. So in this case, we're going to have to multiply the 3 into the brackets. So we will get 2x plus 9x minus 15 is equal to minus 4. Combining these together, we get 11x minus 15 equals minus 4. So 11x is equal to, when the 15 goes over, it equals 11. Running out of real estate, as you can see. So x is equal to 1. All right, well, that gives the x coordinate. We need the y. And this was just like before. So for one of the variables, you get the other one. How? Just by substituting it in. So I'm going to use 1 just because. Get 3x, really, just because. It's the first one. No problem. I'm going to solve for y. So that means the x is going to be replaced with the 1 that we just figured out. So the x is substituted, replaced, and now we just have y to deal with. So we have 3 minus y is equal to 5. Y goes to that side, 5 to that side. You get y is equal to minus 2. Whew, just made it in there. All right, so taking a look at our work, what we did is we took one of the equations, solved for one of the variables. I chose y, just because it was the easier one of the bunch. So this is all solving for y to get it the same thing as something in terms of x, something with an x in it. And then because these are the same thing, we just swap them out. Swapped out the y with 3x minus 5, then algebra, right? It should be understood. 3 goes in, and you get the x value here. One of the coordinates. You need the other one. So you substitute it back in to one of the equations, doesn't matter which actually. And we get y is equal to 2, or rather negative 2. So now we know that this location is going to be at x is equal to 1, y is negative 2. Okay, so different than the picture. It would be down here somewhere. X equals 1, y is negative 2. These lines would be crossing down there. All right, let's do a second example. I'll try and make this a little less. Look at this. It's important to have this neat and organized. It's organized. This part's for the isolation part, solve for y. This is solving for x. Solving for y. Final answer. There's sections everywhere, but not very good. Let's try this one. Actually, no try. Just do this one. So use substitution. To figure out where these lines cross. So for these ones, notice we want to get x by itself or y by itself. It doesn't matter which. So x is almost by itself. We just move the 8y over. And y is almost by itself. Move the 2x over and divide by negative 1. So, well, I think you heard it. This one's 2 steps. That's 1 step. So I'm going to do this one. Okay, so I'm going to use equation 1. I'm going to solve for x. So that creates this situation. X is equal to negative 8y plus 5. So that means negative 8y is the same thing as x. So wherever an x shows up in the other equation, we're going to replace it. We're going to substitute the x. So that's equation 2. So now using equation 2, we have 2x minus y is equal to minus 7. So since x is the same thing as minus 8y plus 5, minus 8y plus 5, we put that in there. Subtract y, minus 7. Okay, algebra. ASA, after some algebra, which are rules that you really should know. And know quickly, I might add. But don't rush. Go fast, but don't rush when you make mistakes then. 2 times minus 8, minus 16. 2 times plus 5, plus 10. Minus y, minus 7. Okay, so get the y's together. Get the y's together. 10 go to that side. So that's a negative 10 minus 7. So you have negative 17y is equal to negative 17. Y is equal to 1. Alright, not bad. Pretty organized still. Let's try and keep it that way. Okay, so we got to figure out what x is now. We got the y, need the x. So, yeah, I can go back to one of the original ones. And honestly, if you're comfortable, you can go back to the x, to what you solved for in part 1. See? That will find it directly. But in a way, I'm seeing this as lost in the inside of the answer a little bit. So I'm going to go back to the original one. I'm going to choose number 1. Why? I think, as you know by now, just because. All right, so that's the equation number 1. We've done some good hard work. We know that y is the same thing as 1. Y is equal to 1. So what's the x? X plus 8 equals 5. X is equal to minus 3. And so the final answer. The lines cross. Because remember, these are lines that we have in the very beginning. General form, mind you, but it's okay. Just one style of writing them. Lines cross at the point, at the location, minus 3 and 1. All right. So this is how substitution can work. You have your equations to start with. Not eliminate, that's the other method. Solve for one of the variables, doesn't matter which. We solve for x. Then in the other equation, and select the other equation, and do the substitution. Do some algebra, should be automatic. After some automatic algebra, it's better. We get that, we get being the y coordinate. And now putting the pieces together, the two lines that we had in the beginning, they cross at the location, cross at the point, minus 3 and 1. Okay. I hope you found this introduction helpful. Okay, I'll follow it up with some samples that are a little more challenging. Stay tuned.